Welcome to our video over the Pythagorean Theorem. Insert clapping sounds here. This theorem tends to be one of y'all's most favorite ones to learn about in our geometry section. I do like to give a little bit of a backstory on the Pythagorean Theorem. So it was invented and discovered by the ancient Greek mathematician Pythagoras, where he found that the square root of both legs added together would give you the hypotenuse of a right triangle. And he actually went into a large proof about this theorem that you will get to learn about in geometry in high school. I'm so excited for you with that. So I get to do the honors of introducing you to the theorem itself, so let's do so. The Pythagorean theorem in a right triangle is the sum of the squares of the lengths of the legs, and it is equal to the square of the length of the hypotenuse. Now, I want to talk about some of these words. First, I want to start out with this piece. In a right triangle, this part is super important that number one, you know what a right triangle is. A right triangle is a triangle that has a 90-degree angle. And I need to make it clear that this theorem only works for right triangles. It will not work for any other sort of triangle. There must be a triangle that correctly uses that 90-degree angle. If you have such, you will be able to use the sum, which y'all should know is the addition sign of the squares, which again we've talked about in the past is a number to the power of 2 of the lengths of the legs. Now, I want to talk about the legs for just a second. The legs are adjacent to the right angle. So if you look over here at our image, you can see the right angle is right here. So we're going to label it right angle. And the reason this theorem only works, now there's obviously way more in-depth reasoning, but the reason that we're going to cover is that the right angle creates straight lines, okay? And we call those lines the legs. Now the legs are the lines adjacent to the right angle, meaning connected to the right angle itself. So we have a leg here. Notice it is attached to that right angle. And then we have another leg here. Think that you have two legs, therefore they have two legs, okay? Now, there is another vocabulary word that was introduced through our definition over here, and it's called the hypotenuse. While the legs are adjacent, the hypotenuse is what we call opposite, okay? Now, opposite of the legs is the hypotenuse. And I want you to notice that the legs are actually shorter than the hypotenuse. The hypotenuse will always be the longest side of your right triangle, okay? So if you want to write that, I would recommend go ahead and reminding yourself that this is your longest side. Perfect. Now, with that comes the theorem. A squared plus b squared equals c squared. I need to reiterate that this only works for right triangles, and that is it. Notice I have a squared plus b squared. These two variables are referring to your legs, so if it makes more sense, I'd recommend putting in a and a b. Now, due to that commutative property, it does not matter which one you call a and b as long as you call the sides adjacent to your right angle, your legs, you're good. It doesn't matter if I call this one B or this one A or vice versa as I have it written. But the one that will always have to be your C is your hypotenuse. The hypotenuse is always C. Notice because it's over here on the other side of the equal sign by itself. Therefore, that is your hypotenuse, your longest side. Okay, so there's the introduction to the theorem. Now let's talk about the solving. So let's start out simple, solving for the hypotenuse. Now this is where I'm going to bring in my calculator here because we have this handy dandy device for a reason. So it says find the length of the missing side and round to the nearest tenth. What I need you to understand is that if you see a right angle, I want you to automatically write down a squared plus b squared equals c squared. I don't care if you don't need it. at least you have associated right angle with Pythagorean theorem. This theorem is found on your reference material, so again, not something you have to memorize, but it is one that y'all typically memorize pretty quickly. Okay, a squared plus b squared equals c squared. Now, the next thing I would like for you to do is label your triangle. You always label A, B, C. Remember that your A and B is interchangeable due to that commutative property. I can switch the order because I do have addition here, but you want to make sure that your legs are always adjacent to your angle, meaning connected to your right angle, and C is always opposite of that angle. Okay, so now the process is actually quite simple. We're going to replace variables with numbers. So A we marked as 12, so I'm going to rewrite the formula. 12 squared. Notice the formula has a plus sign, so we're going to bring that down. Plus, next I have B, so 5, and we're going to put 5 squared because that is what the formula says to do. And I do not know my C yet, so we're going to leave it as C squared. Now, a lot of us might see these squares and get kind of freaked out, but remember your calculator can do that math for you. 12 squared plus 5 squared. Notice I'm just hitting the squared button. You can also hit your caret and put the number 2, but I know that it just needs to be squared, so I'm just hitting that squared button, and I get 169. So I'm going to rewrite 169 equals C squared. Now, where this gets tricky is sometimes y'all forget inverse operations. This was our new inverse operation this year, and the inverse operation of a square is a square root. To get rid of a square, I must square root both sides, because what I do to one side, I have to do to the other. To get your square root, you have, because it's blue, you have to hit second x squared, and then 169, and you get 13. So we get that C equals 13. So the hypotenuse of number 1 is 13 inches. Okay? I would like you to pause the video and attempt number 2. Now, as I'm sure most of you noticed that whenever you typed in your legs, remember your legs are the parts adjacent or connected, if you will, to your right angle. Therefore, there are your legs. Your hypotenuse is your diagonal line. Now, what you should have noticed is that you would have gotten an irrational number because 162 is not a perfect square. So you did get the irrational number 12.72 onto infinity. So we did have to estimate here. It does say it around to the nearest tenth, which is what we did. This 2 does not make this 7 increase. So we got 12.7. Notice I did not put an equal sign because it is not equal. It is approximately. So squiggly equal sign and then C. Okay, so again, pause the video, do number 3. Hopefully on number 3, you also saw that you got the irrational number, the square root of 269, and you did round to the nearest tenth, so 16.4 is approximately C. Alrighty, so hopefully finding the hypotenuse is not as difficult as you may have thought. So now let's close it and let's try to find a leg. So it says find the length of the missing side round to the nearest tenth again. Okay, great. Do you see a right angle? Yes, there is a right angle right here. We're going to shade that in. Now, our legs are the pieces adjacent, meaning attached to that right angle. That's what I'm referring to. So now let's label. I have 7, so we're going to call that A. Now, our first instinct is going to be to automatically call this 25 the B because it is a number. Do not fall for that. Your B is still needing to be attached to this right angle, and 25 is not directly attached to that right angle. Therefore, B in this case is our unknown, and we happen to know C. So whenever I label my formula here, which let me make sure I'm doing the right color, yep, A squared plus B squared equals C squared, we need to make sure that we put our numbers in the right places. So we have A, we're going to rewrite it 7 squared, plus, I do not know my B, so we're going to leave B alone, equals 25 squared. So this one is going to take a little bit more work on our end, so let's rewrite it into numbers we know. 7 squared is 49, I don't know what b squared is, so we're going to leave it alone. And 25 squared is 625. So this is kind of where you have to lean on your remembering how to solve equations. 49 is positive, so to move it to the other side, I have to subtract 49. Those will cancel. I'll be left with b squared equals 625 minus 49, and I get 576. Now I can go into the home stretch here, square root both sides. Those will cancel, and I'm left with, let's see if we have an irrational number here. Oh, we do not. We actually have a rational number. So b will equal 24, that natural number 24. And that would be the final answer. So, as you can tell, you can also solve for the legs. Not always you have to solve for the hypotenuse, so you can solve for the legs at times. Let's go ahead and do number 5 together. So number 5, I see that right angle right there. So I'm going to go ahead and label side A, B, and C. A needs to directly be attached, so we'll call that A. B also needs to be directly attached, so we'll call that B. And then C is on the opposite side of that right angle, so we're going to call this side C. I'm going to move this out of the way for just a second. So I know I have that right angle, so I can write down my Pythagorean theorem. A squared plus B squared equals C squared. Therefore, A squared is going to be rewritten as 13 squared plus, I don't know what B squared is at the moment, so I'm going to leave it B equals, I know C is 16, so we're going to rewrite it as 16 squared. I'm probably going to run out of room, so I'm going to shift up to this side after I do this next part. We're going to rewrite this, so let me bring my calculator back here. 13 to the power of 2 is 169. I don't know B squared at the moment, so we're going to leave it, and then we're going to square 16, and I get 256. So now just that little extra piece, because I do have to move that 169 to the other side. Going to subtract it. Those will cancel. I'm going to be left with B squared equals 256 minus 169 is 87. Travis Kelsey, 87. Now to get rid of that square, we are going to square root, inverse operations. B, let's see if we have a rational or irrational number. We have an irrational number, so we're going to have to estimate. So it is going to be approximately, looks like 9.3. Okay, hopefully solving for legs is not as difficult as it sounds, just you will have to do that extra subtraction piece. So I want you to go ahead and pause the video and attempt number 6. Hopefully you got the approximate answer of 12.6. And as you can see, we found A and B. We don't know our B, so then we plugged in C. The thing is that they start throwing in larger numbers thinking that it's going to confuse you. You have a device to help you. Please utilize your device, and then you'll get the answer correct, 12.6. All right, so I do want to do some word problems because, of course, in the world, it's not always just art problems. Sometimes they like to give it to you in the form of word problems. So I'm going to move this calculator off to the side. Parallelogram PQRT is shown. Which statement proves that the parallelogram PQRT is a triangle? So whenever I look at this shape here, I see PQRT as it says, but then I see that the side 8, let me get my highlighter here, 8 and 15 are connected, and they're connected by a corner. So in this corner, in class we would have the discussion of what y'all noticed about that corner, and hopefully what we could come up with is that this corner here is a right angle. And I did tell you that any time that you have a right angle, I want you to associate that with your Pythagorean theorem. A squared plus B squared equals c squared. If you're able to pull those tools out of your toolkit, even if you don't need them, it is something that might get you your answer or possibly help you eliminate answers that don't make sense, okay? So now it wants us to prove that this is a triangle. Can we do that? Well, sure. These two sides are adjacent, meaning attached to that right angle. So I could technically call this side A or B. Remember, we can interchange those. We do not have to keep them as A and B that way. We could switch them. But for now, we'll write it as is. We'll write 15 squared plus 8 squared. But I do not currently know my C. Remember, C is the hypotenuse. That is the longest side. So we're going to leave that as C squared. Now, let's look at our answer choices here. A says 15 squared minus 8 squared equals TQ squared. Oh, this problem is just simply wanting me to set up the Pythagorean theorem. Well, they have 15 squared minus 8 squared. Is that written correctly? Hopefully you know that the answer is no, because this currently has the legs being subtracted from one another, whereas in the Pythagorean theorem, the legs are actually being added to one another. The next one is B, where I do see the addition sign. However, they only have 8 and 15, not 8 squared and 15 squared like we have it set up. Same thing for C, except they have a subtraction sign and they didn't square our numbers. And then last but not least, we have D, where they have A squared or 8 squared and 15 squared, which I have it in the reverse order, but I am able to reverse that if I wanted to because of that addition sign. And then they have that TQ squared at the end, making D our final answer. So sometimes we're able to just set up the formula and not actually have to solve it. Now, number 8 is the more common way that y'all are questioned, where it says a pole vaulter rests a 17-foot pole against a wall. If the top of the pole hits the wall 14 feet above the ground, how far from the wall is the bottom of the pole? They love to throw word problems at you, and what I love to do is make them into little drawings. Now, my drawings are not the best, but we are going to try. It says a pole vaulter rests a 17-foot pole against a wall. So obviously I have some sort of wall here. So I'm going to draw said wall. Now I'm going to remind you, I'm not an artist. I teach math for a living, so do not come for me here. Here is my wall, and they're saying that the person is going to rest their pole against it. So I don't know about y'all, but whenever I rest something on a wall, I actually lean it. I lean that pole against that wall is what I would assume to think. So I know that the length of this pole that is leaning is going to be 17 feet. Okay? Now it says if the top of the pole hits the wall 14 feet above the ground. Oh, so then this right here must be the ground. I mean, I could draw a little tree if I want to, but that would take up a lot of time. So here is the ground here, and it's saying that the wall is 14 feet above the ground, so they must be saying that this is 14 feet. Okay? Now, it wants to know how far is the bottom of the pole from the wall. So they're wanting me to figure out this piece right here. Well, hopefully you can see that what we just drew can be made into, let me get a different color here, a right triangle, because the pole is leaning against a wall, and I'm trying to figure out how far the bottom of the pole is from this wall, thus giving me my right angle, meaning my light bulb should be going off. I said right angle. I created a right angle. I need to write down my Pythagorean theorem. Even if I don't need it, I might be able to use it because it is a right triangle. Now, let's see if we can use it. I do have a right triangle, so I should be able to label. I sure can. A is attached to the right angle. B is attached to the right angle. C is opposite of the right angle. I'm going to go turn my lights back on 1 second. Sorry about that. So now I can take this image that we created. Now notice they just gave me a blank space. You draw your image yourself. Fill in your numbers. 14 squared plus, I don't know my b, so I'm going to put b squared equals 17 squared. So it's all about understanding the vocabulary of what they're saying. They're saying that the 17-foot pole rests. Well, when you rest something, you lean it. Therefore, there's your hypotenuse. That the wall hits 14 feet above the ground. Well, here's the ground. Here's 14 feet above it. That is a leg. You are trying to find the distance between the pole and your wall, which again, another flat surface. Therefore, it's going to be another leg. Now, I want you to pause the video and I want you to solve your equation. Hopefully, you got that your other leg is approximately 9.6 feet away from your pole. So there is a 9.6 gap here between the wall and the bottom of your pole. Okay, hopefully y'all enjoyed the Pythagorean Theorem as much as I do. This is one of my favorite lessons I get to teach all year. So please, and I hope you enjoyed this video. Let me know if you need any more help, and I'll see you in the next one. Bye.